The moment that image exploded across every corner of the internet, I knew something wasn't right. Not because it wasn't beautiful. Its swirling blues, fractured icy ridges, and perfectly etched tail were exactly the kind of thing people imagine when they picture a visitor from another star system. But because it was too perfect, too polished, too confidently labeled as JAXA's first detailed image of interstellar Comet 3 I/Atlas. That was the first red flag. JAXA hadn't said a word. NASA hadn't confirmed anything, yet millions of people reposted it as if it were a scientific fact carved into stone. The truth is, I've spent my career hunting for interstellar visitors, objects, signals, debris, and anything that betrays the existence of something born beyond our sun. I know how rare they are. I know how sensitive scientists are when dealing with claims about objects that do not originate from the solar system. And I know how carefully space agencies communicate data, especially when something as monumental as an interstellar comet is involved. So when I saw that viral post claiming the Japanese Space Agency had released the most detailed real image of 3I/ATLAS using spectral composite imaging, I had only one reaction: no, they didn't. The original post came from an anonymous account on X. No affiliation, no credentials, no explanation of the alleged source. Just a single line of text and the image attached. But the internet doesn't wait for verification. Within hours, millions believed it. News aggregators picked it up. Influencers reacted to it. People debated whether the shape in the photo meant the comet was fragmenting, or if its surface texture hinted at exotic chemistry, maybe even organic compounds from a star system older than ours. The memes spread even faster than the misinformation. I watched the excitement rise, and I understood why. Interstellar objects are irresistible. Every time one enters our cosmic backyard, we're witnessing something that has traveled for millions or billions of years, an artifact carrying the chemical fingerprints of a place humanity has never seen. When Oumuamua passed through in 2017, the world became obsessed with its cigar-like shape and anomalous acceleration. With 2I/Borisov in 2019, we finally saw a true interstellar comet behaving like one. And now, with 3I/ATLAS announced after its discovery in July 2025, the anticipation has been extraordinary. People want to see it. They want something tangible they can point to and say, that came from another star. I understand that longing more than most. But science doesn't bend to longing. Within the first 20 minutes of the viral post, astronomers began raising alarms. Some recognized the rendering style from an AI model widely used for astrophotography art. Others pointed out inconsistencies in the spectral coloration, specifically that the image's supposed spectral composite mapping looked nothing like how JAXA processes raw science data. And as I scanned the comet's tail in the picture, the texture was too smooth, the gradients too cinematic. Real spectral composites don't look like paintings. But the biggest problem was simpler. At the time that image surfaced, even the existence of 3I/ATLAS had only just begun circulating through scientific networks. Public confirmation hadn't fully propagated. The comet had not been imaged in high resolution by any spacecraft. It was far too distant, too faint, and moving too fast. Ground-based observatories barely had enough signal to establish trajectory and interstellar origin. The idea that JAXA had somehow acquired a crystal-clear, close-range photo without any official announcement was absurd. Yet the public loved the image anyway. They shared it because it made them feel part of something cosmic, something historic. A new interstellar object, only the third ever confirmed, ignites imagination. And that emotion, that desire, is powerful. It can overwhelm caution, skepticism, or scientific literacy. It can turn a well-rendered fabrication into a worldwide phenomenon. What struck me most wasn't that the picture was fake. It was that the global reaction revealed how deeply people hunger for connection to the universe beyond Earth. They want evidence, wonder, mystery, something that disrupts ordinary life and reminds them that the cosmos is wide, ancient, and full of travelers crossing the dark between stars. Even if the image was fabricated, the excitement was real. But misinformation, even when born from awe, still threatens scientific integrity. People began citing the image in online debates about comet composition. They claimed it showed alien-like structural patterns. They used it to argue for theories that had no connection to real data. I watched as the fake image became a seed for entire forests of speculation, some harmless, others potentially damaging. And still, as I scrolled through the endless stream of reposts, one thought stayed with me. This reaction is a preview of what will happen the next time a real interstellar visitor is photographed up close. We must prepare for that moment, because unlike this viral imposter, 3I/ATLAS is absolutely real. Its discovery is valid, its trajectory unmistakably interstellar, its destiny already written in the dynamics of the solar system. It will swing around the sun on October 30th, 2025, moving too fast for any spacecraft to catch, then disappear into the night forever, carrying stories from another star. If we want the truth about it, we must learn from this moment. We must separate fascination from fabrication, curiosity from credulity. Before this comet leaves us behind, we owe it to ourselves to understand what is real and what never was. The more the image spread, the louder the scientific community had to shout just to be heard, but the internet rarely pauses to listen. By the time credible astronomers attempted to correct the narrative, the myth had already grown roots. People weren't just sharing a picture anymore. They were building entire explanations around it. Some claimed the crystalline ridges on the comet's surface indicated cryovolcanic activity. Others insisted the visible striations in the tail proved it was shedding exotic material not found in our solar system. All of it derived from a picture that never passed through a single scientific review. It reminded me of how information behaves in the digital era. Data travels at the speed of light, but truth moves at the speed of bureaucracy. And that gap, the space between what people want to believe and what has actually been verified, is where confusion thrives. I saw that gap widen in real time as experts tried to rein in the speculation. Colleagues from Japan reached out privately to confirm what I already knew. JAXA had made no such release. If they had anything worth showing, it would have gone through a formal press briefing, complete with timestamps, mission context, and technical documentation. Instead, silence echoed from every official channel. Silence, which the public interpreted as mystery or even conspiracy. That's the thing about absence. People rush to fill it with their own narratives. I found myself fielding calls from news outlets asking whether I believed the image could still be authentic. My answer was blunt. Extraordinary claims require extraordinary evidence, and this claim had provided none. The lack of provenance alone was disqualifying. But the deeper problem was that the image was being taken as a symbol rather than a data point. It satisfied the collective imagination far too neatly to be trusted. Meanwhile, astronomers around the world continued gathering real observations of 3I/ATLAS, none of which looked anything like the viral photo. At that distance, even our best telescopes saw only a faint, elongated smear of reflected sunlight. There were no sharp edges, no intricate surface textures, no cinematic hues. Just the authentic subtlety of a distant interstellar traveler gliding past us at nearly 210,000 kilometers per hour. Yet people clung to the glamorous version instead. I couldn't blame them entirely. Interstellar objects have always straddled the line between science and mythology. For thousands of years, comets were interpreted as omens, ghostly messengers crossing the sky, announcing upheaval, warning of death or change. Even now, with all our modern instruments, we haven't fully shaken that instinct. When an object from another star system visits us, it triggers something ancient in our psyche. A sense that we're being observed in return. A sense that the universe is sending a message through the void, and maybe it is, but not the one people think. 3I/ATLAS is remarkable precisely because it doesn't need embellishment. The mere fact that it is interstellar means it carries the chemical memories of another birthplace. The dust trapped within its nucleus could predate the sun itself. Its shape, rotation, composition, these are clues about environments we will never see with our own eyes. Even without a beautiful photo, it is a gift. A messenger, yes, but one whose message must be decoded with patience, not fantasy. What concerned me most about the viral image wasn't the image itself. It was what it revealed about our relationship with truth. We live in an era where visual authenticity can be forged with a few clever prompts. AI can fabricate a comet, a spacecraft, or an entire alien vista in seconds. And because our minds respond more strongly to visuals than text, the emotional impact of a convincing image can outpace facts by orders of magnitude. So the question isn't just whether the picture is fake. The real question is, how do we maintain scientific credibility in a world where the line between observation and imagination is dissolving? How does the public develop the discernment needed to navigate a cosmos filled not only with mystery, but with manufactured illusions? I thought about that as the debates intensified. People began arguing not about the science, but about the legitimacy of skepticism itself. To some, doubting the image meant undermining the awe they wanted to feel. To others, questioning the authenticity was an attempt to gatekeep wonder. The internet has a way of making skepticism feel like cynicism, even when it's simply the first step toward understanding. Yet, beneath all the noise, something encouraging emerged: global curiosity. Even those who misunderstood the image were drawn to the underlying story. 3I/ATLAS, a genuine interstellar visitor, racing through our solar system on a one-way trajectory. They wanted to know where it came from, what it was made of, how fast it traveled, and why it mattered. They were hungry for knowledge, not just spectacle. That is the part I hold on to. The fascination is real, even if the picture is not. And fascination, when paired with guidance, becomes education. In the coming months, as Atlas approaches perihelion, we will gather better data, actual spectral readings, refined orbital models, improved imaging through stacked exposures, and noise reduction algorithms. No, we will not get a dramatic close-up, but we will get something far more valuable: truth. And truth, though often less glamorous, has a way of enduring long after the viral illusions fade. The turning point came when the public finally began asking the question that should have been asked from the start. If the viral image wasn't real, then what did we actually know about 3I/ATLAS? Not the fantasy, not the cinematic rendering circulating online, but the verifiable, peer-reviewed truth. And the truth, while less dramatic than the fabricated portrait, was far more awe-inspiring to me. I began explaining to anyone who would listen that 3I/ATLAS wasn't just another comet, it was the third confirmed interstellar object ever detected, and that alone made it historic. It was first picked up on July 1st, 2025 by the Atlas Survey Telescope in Chile. A faint, fast-moving point of light that didn't match the expected motion of any solar system body. Its trajectory hinted at an origin beyond our sun's gravitational influence, and as additional observations poured in, the picture became clearer. Its eccentricity was far greater than 1, its incoming velocity too high to be bound. Everything about it pointed to a birthplace somewhere outside the Oort cloud, outside the sun's family, outside everything we call home. When NASA ran its orbital models and confirmed the interstellar origin, the scientific community reacted with a mix of excitement and urgency. These objects do not give us second chances. They arrive without warning, whip around the sun, and disappear forever. There is no sending a spacecraft after them, no time for a rendezvous mission. All we can do is observe from afar, collect data as quickly as possible, and hope we gather enough clues before the universe pulls them back into the dark. 3I/ATLAS is no exception. In fact, it's moving faster than either Oumuamua or Borisov, about 210,000 kilometers per hour. That is not a speed you can negotiate with. It's the speed of a cosmic tourist who refuses to stop for souvenirs. By the time most people on Earth heard its name, it had already crossed the outer boundary of the solar system and was accelerating toward its inner arc. It will reach perihelion, its closest point to the sun, on October 30th, 2025, and then just as quickly it will vanish into interstellar space again. I find that kind of trajectory poetic. A visitor who arrives unannounced, travels through our celestial neighborhood for a brief moment, and leaves us wondering where it came from and what ancient stories it carries within its icy core. But poetry must not replace accuracy, and that's where the viral image did the most damage. It gave people the illusion that we had intimate access to something we could barely resolve in a telescope. It overwrote the humility required when studying an object we will never touch. Still, the renewed interest gave me an opportunity to explain what makes an interstellar comet scientifically priceless. These objects are messengers from entirely different star systems. Their chemical signatures encode information about environments that formed billions of years ago, long before Earth even existed. Their isotopes might reflect temperatures from distant molecular clouds. Their dust composition could reveal details about stellar nursery conditions across the galaxy. Every atom inside an object like Atlas is a time capsule from a cosmic origin we may never visit. That is why scientists did not need a gorgeous image to appreciate its significance. We cared about the spectral fingerprints, the absorption lines that reveal the presence of carbon chains, water ice, ammonia, silicates, or something entirely unexpected. We cared about how sunlight scattered off its coma, how its tail curved under solar wind pressure, how its brightness changed as it heated. These subtle measurements are what tell us whether ATLAS resembles comets from our own solar system or whether it contains material foreign to everything we've catalogued so far. As I watched the public discourse evolve, I realized something important. People weren't merely attracted to the fake image, they were hungry for understanding, and when given the chance, they engaged with the real science more deeply than I expected. They asked about orbital mechanics, about hyperbolic excess velocity, about whether interstellar comets could carry complex organics or even prebiotic molecules. I found myself discussing the chemistry of star-forming regions with people who had never studied astronomy. The curiosity was genuine. But with that curiosity came another challenge, the rise of conspiracy theories. Some individuals insisted the image must have been real and that agencies were simply hiding the truth. Others believed the comet's unusual path indicated intelligent control. The idea that Atlas could be an alien probe resurfaced, just as it had with Oumuamua. It seems that whenever the universe sends us something unfamiliar, we project intelligence onto it. Perhaps it says more about us than about the objects themselves. I addressed these claims directly. An interstellar comet traveling at extreme speed, following a predictable gravitational trajectory, shedding material exactly as expected from a volatile-rich nucleus. None of that aligns with deliberate engineering. Nature is capable of producing extraordinary shapes, movements, and phenomena without invoking extraterrestrial architects. To look at an ancient traveler shaped by cosmic forces and insist it must be artificial is to underestimate the universe's creativity. Still, I understood the impulse. People want meaning. They want connection. When faced with an object that has traveled millions of years to pass by our sun, it's tempting to assign purpose to it. But the real wonder lies not in fantasy. It lies in the recognition that the universe is filled with wanderers like Atlas, forged in fiery birthplaces we will never see, and their arrival in our skies is a rare reminder that we are not isolated. We are part of a galactic ecosystem of drifting relics, each carrying the memory of a different origin. As October draws near and Atlas approaches its closest dance with the sun, I know the speculation will intensify again. People will want images, real ones this time. They will search for meaning in every update, every data release, every spectral reading. And while we may not get a photograph worthy of a movie poster, we will get something far more valuable, a truthful scientific record of an interstellar messenger passing through our cosmic doorway. And sometimes honesty is far more astonishing than myth. As the dust settled around the viral image, something unexpected happened. The conversation shifted from the fake picture to the deeper question of why humanity is so captivated by anything labeled interstellar. People weren't just debating authenticity anymore. They were asking what it means for an object like 3I/ATLAS to pass through our solar system at all. Why is the arrival of a visitor from another star so emotionally charged? Why does it stir both fear and fascination, skepticism, and longing. I've thought about this for years. Every time I speak publicly about Oumuamua, someone asks whether it might have been artificial or whether interstellar objects could represent messages or even mistakes from distant civilizations. Those questions don't come from ignorance. They come from a very human impulse, the desire to believe we are not alone and the desire to find meaning in cosmic events. A comet that has crossed the gulf between stars feels like a courier delivering something important, even if the message is nothing more than the fact of its existence. But scientific significance does not require myth. Atlas is already extraordinary by virtue of being real, rare, and unbound by our sun's gravity. And as more people learned the truth, they became increasingly curious about its behavior, composition, and larger context. I found myself explaining that Atlas is not just an isolated curiosity, it's a sample of a much larger population of interstellar objects drifting between stars, remnants of planetary formation processes happening everywhere in the galaxy. Each one that enters our system is a chance to understand how common planetary systems like ours truly are. And that, I realized, is why the viral image struck such a nerve. It gave the illusion of intimacy with something profoundly remote. It made the universe feel smaller, more accessible, easier to grasp. But the actual science paints a different picture, one that is humbler but far more powerful. The real ATLAS is distant, faint, and fleeting. It forces us to accept the limitations of our technology and the vastness that separates us from other stars. It requires patience and methodology instead of spectacle. Still, misinformation thrives when real information feels inadequate. I knew that if scientists wanted to regain control of the narrative, we had to do more than debunk a photo. We had to replace the void with real substance. So I began speaking publicly about what we could learn from ATLAS, even without a glamorous image. I talked about spectroscopy, the way starlight passing through its coma can reveal chemical signatures. I talked about the value of determining its isotopic ratios, its dust grain distribution, its reaction to solar radiation pressure. None of that makes for an exciting headline, but it is exactly the kind of data that advances our understanding of the galaxy. Something interesting happened then. People responded. They shared the real science. They asked for updates. They dug into the raw observational data from ground-based telescopes, and in doing so, they did something more meaningful than sharing a viral picture. They participated in the process of discovery. Even those who first believed the fake image began to appreciate the careful work behind real astronomy. But this renewed curiosity came with new misconceptions. Some began assuming that because ATLAS was interstellar, it must be radically different from comets formed in our system. They imagined exotic chemistry, alien isotopes, wholly unprecedented structures. Others became convinced that its high speed implied some form of propulsion. I addressed these claims directly. Interstellar objects do not need exotic explanations to be remarkable. Their velocities reflect the gravitational dynamics of their home systems and the chaotic processes that eject them into galactic space. Their compositions, while potentially unique, are governed by the same physics that shaped our solar system. And yet, I didn't want to dampen the sense of wonder. Wonder is fuel for scientific progress. The challenge is guiding it so it doesn't drift into fantasy. I found myself walking a delicate line, encouraging fascination while discouraging unfounded speculation, explaining uncertainty without diminishing significance. One question kept recurring: what kind of star system did Atlas come from? The answer is both simple and profound. We don't know, and likely never will. All we can say is that it once belonged to a system with gravitational dynamics strong enough to eject it. It might have formed around a young star, drifted for billions of years, survived interstellar radiation, and finally encountered our sun by sheer coincidence. That randomness is part of the beauty. The cosmos is full of wanderers, and Atlas is one of them. As October approached and the comet moved closer to the inner solar system, observatories intensified their efforts to track and analyze it. The data was getting better, but never in a way that would satisfy those still hoping for a cinematic portrait. And I knew that when perihelion arrived, people would once again look for images, real ones this time, and feel a mix of awe and disappointment when they realized that real astrophotography is subtle, imperfect, and constrained by physics. But perhaps that contrast is necessary. The universe is not here to perform for us. It reveals itself slowly, through faint signals and distant glimmers, through data that must be interpreted rather than admired. The fake image gave people a fantasy. The real atlas gives us something far more valuable, a chance to confront the vastness of the galaxy and recognize our place within it, a chance to learn. And as its path carried it ever closer to the sun, I could feel the anticipation building again. Questions multiplying, expectations rising. The world was ready for answers, real ones this time. And the only question left was whether we would listen. When the final weeks before perihelion arrived, the world seemed to hold its breath. People who had never looked through a telescope were suddenly tracking orbital diagrams, refreshing observatory feeds, asking when the real picture of ATLAS would finally appear. What they didn't fully grasp was that the reality of interstellar astronomy is built on faintness, uncertainty, and patience. There would be no close-up silhouette, no sharp-edged crystalline contours, no dramatic tale sculpted like a painting. There would only be data, quiet, stubborn, honest. And perhaps that was the lesson we needed. As Atlas swept closer to the sun, the real observations finally overtook the viral myth. Spectral readings confirmed a familiar cocktail of volatiles, water ice, carbon-based molecules, traces of silicate dust. Nothing exotic, nothing implausible, yet profoundly significant because these materials were forged somewhere far beyond our solar birthplace. The excitement didn't come from novelty, it came from context. The atoms in this comet had survived a journey so long and lonely that human imagination can barely grasp its scale. I spoke about this publicly as often as I could. I told people that the importance of Atlas was not in its appearance, but in its origin. That the dust escaping from its nucleus was older than Earth. That by studying its behavior near the sun, we were peering into the conditions that shaped planetary systems across the galaxy. And slowly, I noticed the conversation shifting from the disappointment of the fake image to the wonder of the real object. Curiosity began to anchor itself in evidence rather than illusion. But what struck me most was the global response to the idea that Atlas would leave us forever after October. People described a surprising sense of melancholy, as if losing a visitor they barely knew. They followed its countdown like a farewell ceremony, and in those reactions I recognized something deeply human, the instinct to assign meaning to transient things. A comet that stays only briefly becomes a mirror. In its passing, we reflect on our own impermanence, our own smallness, our own longing to connect with something larger than ourselves. When Atlas finally swung around the sun, brightening for a moment, then fading, it left behind no spectacle, no revelation, no cosmic message etched in ice. But it left a trace of something far more important, a reminder of how easily we blur the line between what we want and what is real, and how essential it is to restore that line whenever it begins to erode. In the aftermath, I revisited the original viral image, not with frustration, but with a renewed understanding of why it captured the world so quickly. People are eager for discovery, eager for beauty, eager for a story that makes the cosmos feel close enough to touch. And while the fake image provided momentary wonder, the truth offered something lasting, perspective. 3. I/ATLAS came from another star system, crossed unimaginable distances, and revealed itself only as a faint blur of reflected sunlight. Yet that blur is enough to rewrite scientific models, challenge our assumptions, and remind us that our solar system is not isolated. Objects pass between stars. Matter travels. Stories migrate. The galaxy is not quiet. It is alive with movement. As Atlas recedes into the deep night, speeding toward a future we will never witness, I am reminded that the universe doesn't need our embellishment to be extraordinary. It simply needs our attention, our rigor, our humility, and our willingness to follow evidence wherever it leads. The fake image will fade, as viral moments always do, but the truth of Atlas, the real, fragile, fleeting truth, will remain a part of our scientific record long after the comet itself vanishes beyond the reach of any telescope on Earth. And in that truth, we find something better than spectacle. We find our place in a galaxy vast enough to surprise us, honest enough to challenge us, and generous enough to send us visitors from other suns, whether or not we're ready for them,